Hello, this is the first video for Chapter 4, and Chapter 4 is about systems of first-order differential equations. And just as an introduction to this, I'll say that Chapter 4 is mostly a repeat of Chapter 2. Because we're looking at first-order differential equations, so that was what we started off with. I'll say with some linear algebra added in. So linear algebra is a prerequisite for taking introductory differential equations, but since it plays such a big part in this section, I'm going to talk about some topics in this video and the next video as well, just in case you've forgotten how to do some things like take the determinant or solve algebra with matrices. So in this video, I'm going to be talking about matrix algebra, I'm going to talk about notation, since I'll be trying to match the notation in the book for the most part, and that might be different from what you may have seen before. We'll talk about taking determinants, both the 2x2s and 3x3s. And also talk about inverting matrices. That's sort of a part of matrix algebra. Okay, this is not a complete list of what I'll be talking about, but that's sort of the main topics that I'm going to be going over. The next video we'll talk about things like eigenvalues and eigenvectors. But the good news is that once you know how to do the linear algebra in here, there's not a whole lot extra to learn. We're going to be using a lot of concepts from Chapter 2 and just applying them multiple times. But to start off, I'll just say that my notation I'm going to use this little arrow on top here and say that this indicates a vector which has dimensions, let's say n by 1. So if I wanted to write that out, in multivariable calculus you may have seen notation that uses something like this, but I'm going to stack them horizontally. So this is going to have components x1 and x2 and x3. Something you should note is that in the book, instead of writing this little arrow on top, what the book will often do is write y. Let's say they wanted to make this into a vector. They're going to bold that y in there, but you can kind of see the trouble I'm having trying to bold this. And it's going to be very time consuming to do that when I just want to write something quickly. So when you're going through reading the book, just make sure you look out for bolded things. But my notation for the same thing would just be y with an arrow on top of it. That's going to be really important to distinguish between what's a variable or an element of a vector like this and what's a vector and what's a matrix later on. So anytime I draw an arrow, that's a vector. Anytime I don't draw an arrow, it's not a vector. And I'm pretty good about staying consistent with that. A capital letter like this capital A here, will denote a matrix in this chapter. And the input's going to be T there. So the convention for naming the elements of this, I'll start with a 3 by 3. So in the top left corner we have A11, A12, A13, so on and so forth. What I do to keep track of these, or to remember, for example, this one is this A32 or 23. I like to read these. I know this represents 1, the row, and 1, the column, but I can think of this as being like 11, 12, 13. So you would sort of put these numbers in order as you would read them in a book, left to right, and then down to the next row. But some specific examples of these that we're going to see. We are going to be looking at, say, the vector y, for example, is going to be our solution vector, and that's going to consist of, in this case, I'll just say 3 elements, and we'll label them like this. I might also talk about a y prime vector. So the elements for that are just going to be y1 prime, y2 prime, and y3 prime. I won't be telling you this. My expectation from now on in this class will be that anytime I say y or y prime, you'll be able to make these vectors there. Another thing that you'll see in this course is the matrix P of t. And that's going to consist of in the 2 by 2 case, that's going to consist of 4 functions of t. Our g of t in this case, so that's similar to our g of t that determines whether something's homogeneous or non-homogeneous. This is going to be now the g vector, so that's going to consist of a g1 and a g2. And that would be for our 2 by 2 case. Just take an extra look at these before you dive into this chapter. Knowing how to move in between these 2 forms is going to be really helpful. Okay. Here's some basic algebra. So I'm going to give us 2 matrices, and I won't make you watch me write them. Finish those up. Okay, so 2 matrices A and B, and if I want to multiply these 2 matrices together, matrix multiplication happens like this. I'm just going to copy paste these. This must be painful to watch. Sorry about that. So this is going to result, let's see, we're multiplying a 2 by 2 matrix by a 2 by 2 matrix. So for the dimensions, there's not a whole lot of options, but you can think about these two dimensions are going to determine the dimensions of the resulting matrix when we multiply these two together. So it's going to be 2 by 2. This first term here, the way we do matrix multiplication is that this term, I'm going to give myself lots of room here, is going to be the first row from the first one, since it's the top row, and the first column from this one. So we start with the first term, or the leftmost term here, and the topmost term here. So this is going to be A11 times B11, since that's the left and topmost term, and that's going to be plus A12 times B21. And I'll do one other term here, so let's say this one down below here. So that one's going to be the second row, so I'll use these terms here. And it's still in the first column, right? We're going to have two more entries over there, so I'm still using the first row here, or sorry, first column. So this will be A21 times B11 for my first term, plus A22 times B21. All right, I will finish this up, and you can see the results there. Okay, so this is the result, and you can see if you agree with that. Taking the row from the first one and the column from the second one, that'll give me a 2 by 2 matrix. One other note on this, I will say that order matters. All right, so A times B is not going to be the same as B times A, so we do need to think about that. There's a couple pieces of calculus that we can apply to matrices that you would probably do on accident, even if I didn't tell you how to apply them. But if we take the derivative with respect to t of a matrix, that's going to be denoted with a dash there. But this will just be the individual derivatives of all the individual entries. Same thing with taking the integral of a matrix. That's going to look like the individual integrals of all these individual. They'd probably be more interesting if these were all functions, but we could take their integral if they were just values too. What this results in is we have these antiderivatives. So we have all these kind of pieces here. So these are all our antiderivatives, where this is your 1/3 t to the third. But each of these individually is going to have a plus c, plus c, plus c, plus c. So I'm going to add this to here, and rather than add plus c to everything, I'm just going to call this a constant matrix. And that's going to have entries that look like this. So we'll have C11, C12, and so on. So most of the time it'll be nice to be able to split it up like that and just have all your constants over here. If you want to apply the product rule, there's a couple instances where you might need to do this where, let's say you have A times B, and you need to take the derivative of both of those, or the product of both of them. You might know from Calculus 1 that if you have f times g and you want to take its derivative, then you're going to get, somebody told me they learned that this was fig gif, right? And this is totally fine for Calculus 1 if you've just got two functions here. But this order is not okay for matrices. So like I said, the order in which you multiply matrices together matters. So if I have A times B prime, then I have A out in front and B second, and I need to retain that order. So this would be A prime times B plus A times B prime. Again, so I'll say order matters.